Last lesson of the chapter, section 1.9. And we're going to start off talking about, we did inequalities. Well, yesterday's lesson was inequalities, wasn't it? We graphed some inequalities, didn't we? The open circle, closed circle, arrow to the left, arrow to the right kind of stuff. But now, since we did absolute value yesterday, we are going to do some graphing with absolute values. And we're going to do inequalities as well. All right, so what if let's talk about absolute value. Have we talked about absolute value yet in here? Yeah, yesterday's was absolute value. I can't remember anything. Yeah, so what did we say? So like, what's the absolute value of -3? That would be +3. That means what is the absolute value of x? It's positive x and it's negative x. All right? Everybody got that? Okay. So because I could put a 3 in for the absolute value and get 3, and I could put a -3 in for the absolute value and still get a 3. All right? Same thing with this. If I put a -x in for this, I'm still going to get an x. Put a positive x in for this, I'm still going to get just a positive x. All right, enough said. So let's do a little graph right now. Absolute value of x is greater than 3. So we got to find all the values of x that make this a true statement. You could probably sit and think of a few numbers, right? Put them in there. But we want, yeah, it's not just one number. All right, and it's greater than, and do you remember what we did on that last lesson? We made one plus and one negative. All right, so what does this mean? This means that x could be greater than 3, and x could be, now let's think of this next one, because this one's an inequality. Yesterday we did equals. We just said, if this let's go back to yesterday. If you had this, what would your answer be? It would be x equals +3, and what else? X equals -3, agreed? But this is an inequality, so it's a little different. So how am I going to write that? Let me, yeah. So don't write this next thing down, okay? Because this is not correct. I'm going to show you. A lot of people would say, oh, I'm just going to write that greater than and make that a negative. It's kind of like what we did yesterday, isn't it? Right? We make one, we just keep it the same, then the other one we change it. But let's think about this. This says x can be greater than a -3. So what if I put, what's a number, an easy number that's bigger than -3? Don't give me something huge. Give me even something smaller, like a -2. All right, let's go -2. Would you agree? So -2 is bigger than -3. But if I put a -2 in for this, what's the absolute value of -2? It's 2. Is 2 greater than 3? No. So this cannot be greater than. It needs to be, what do you think? Right, because when I have an inequality and I make the other side negative, I have to change the direction of the inequality. So this is what we're going to write, and then we're going to put an or in between. So when you see the absolute value with an inequality, you keep the first one exactly the same. You just get rid of the absolute value. But the second one, you don't just change that to a negative. What do you have to do to the inequality? You got to switch that as well. Everybody watching? Okay. So now we're going to graph it. I'll tell you what, let's do this. So we've got a -3 here. We've got a +3 here. How do we graph this? This says x is greater than 3. So what kind of a circle do I put here? Open circle, and I shade which direction? For this first part right here. Thank you, to the right. Okay? Now, what do I do here? This says x is what? Less than negative 3. And I'm going to shade to the left since it says less than. And that is my graph. Let's just pick a couple numbers to see what works. Let's pick an easy number in between. So it looks like none of the numbers in between are going to work. What's a real simple, easy number we can plug in that's in between negative 3 and 3? Okay, well, let's put a positive 2. So what's the absolute value of 2? It's 2. Is 2 greater than 3? No, it's not. That's why that's not shaded in. You can pick any number in between negative 3 and 3. Pick a 0. What's the absolute value of 0? 0. Is 0 bigger than 3? No, it's not. Let's pick a number that actually does work. Let's pick a number to the left of negative 3. Give me an easy number to the left of negative 3. Negative 5. Let's put a negative 5 in for this. What's the absolute value of negative 5? 5. Is 5 greater than 3? Yes, it is. Okay? And of course, if you put a number that's greater than positive 3, let's pick a 4. All right? What's the absolute value of positive 4? It's 4. Is 4 bigger than 3? Yes, it is. Do you see how it works? All right, so the red includes all the possible answers, and the stuff that's not shaded in, stuff in between here, does not work. And that's what this graph does for us. Let's do another one. Let's see the difference between this one and the next one. So, let's keep this white. All right, what if I said the absolute value of x is less than 3? Not greater than, but less than. So what am I going to do? I'm going to write down two things. I'm going to write x is less than 3. Now this time, well, I'm not going to put the word just yet. I'm just going to write it down here. What do I do with that? I got to write it twice, right? The first time I write it just the way it looked to begin with. All right, now I got to change a couple things, don't I? What do I change? I change this from a less than to a what? To a greater than. Change this from a 3 to a negative 3. And let's see what this looks like. So here's my graph. I got a negative 3. I got a positive 3. What does this say? This says x is less than 3. All right, so here's 3. So it's less than 3. I'll put that word in there now. And this means and x is greater than negative 3. So I want to find out where they overlap. So x is less than 3, x is greater than negative 3. Where do they overlap? Everything in between. So that's your graph with this. So if it's less than, it's going to be an and. If it's greater than, it's going to be an or. And this is what they're going to look like. We got it? Let's try some numbers. Let's try a number in between negative 3 and 3. What's a super easy number between negative 3 and 3? Okay, 1. Let's put a 1 in there. So what's the absolute value of 1? It's 1. Is 1 less than 3? Yeah. So you can pick any number in between here in the red. It's going to work. Let's pick a number outside the red. Let's pick a number here. Give me an easy number. Negative 5. What's the absolute value of negative 5? It's 5. Is 5 less than 3? No, it's not. So it doesn't go here. Same thing here. Pick a positive 5. Absolute value of positive 5 is 5. 5 is less than 3. Or 5 is not less than 3, I should say. So you don't shade here. See how it all works? All right, so this is greater than. This is less than. All right. That wasn't an official example. Example 1 looked basically just like that. What's the only difference? So like if I put a or equal to, what's the only difference here? If I said less than or equal to, the circles would be shaded in. That's the only thing different, okay? There's no or equal on these, so that's why they're open circles. We good? All right, let's do example 2. Says solve and graph, okay? Solve and then graph. Oops, what am I doing? All right, there you go. So which direction do you think the shading is going to go? Do you think it's going to go to the outside, or is it going to shade inside the two points? Look at your notes. What did the last one do? The less than was shaded inside, wasn't it? All right, so you already have in your mind how this is going to shade. We got it? All right, so now let's do our work. It's very similar to what we did in the last homework, right? Section 1.8. But you got an inequality, so you got to change one more thing. So right now we just write it exactly the way it looks without the absolute value. So we're just going to write that, okay? And then we're going to keep that the same, but we got to change a couple things now. We're definitely going to change that to a -4, but what do we have to do to the inequality? We got to change that direction too. So instead of less than, it's going to go greater than, and we got to change the 4 to a -4. So that's the thing that you got to change. Those two things right there, you're going to have to change in your second inequality. Can you remember that? That's super important. That's really the whole gist of this lesson, is that part right there. All right, let's solve for x. So we just do this in our head. Add a 7, so 2x is less than 11. Divide by 2, so x is less than 11 over 2. What is 11 over 2 if we're going to graph it? 2 goes into 11, what, 5 times? 1 over 2. So we're going to write x is less than 5.5. Everybody got that? Okay, let's do this one. Add a 7. So if I add a 7 to this, what am I going to get? I'm going to get a +3. Divide both sides by 2, so x is greater than 3 over 2. What is 3 over 2 if we're going to graph it? 1.5. Okay, so those are my answers. It says to solve and graph. So that's my solution right there. That answer and that answer right there. You could keep it 11 over 2 and 3 over 2. I'd be perfectly fine with that. The only reason I change it to these mixed numbers is because I'm going to have to graph it, and I need to know, like, where is 11 halves on my graph? Well, it's at 5.5. Make sense? Okay. So what's the smaller number? 1.5, right? So I'll just put 1.5 right there. I don't even have to put all the dotted things. Then 5.5, put that right there. Now what does this say? It says it's less than 5.5, and remember, the less than means and it's greater than 1.5. So where am I shading? Everything where? In between, right? But they're going to be open at both ends. Why they're open at both ends? Because neither one of these is or equal to. And then I go ahead and shade everything in between. And that's my graph. There's my solution. There's my graph. Simple as that. Ready for another one? Yeah. Again, solve and graph. This is example 3. Change this back to white. All right, here we go. We're going to solve and graph. And it's -4x plus 9 minus 11 greater than or equal to 4. It's hardly any different than what you did on the homework yesterday, except for that inequality part. All right, so look, you got a -11. I don't want that. What do I want to do with that? I'm going to add an 11, correct? Everybody see that? Now I can work this thing out. So let's just write it out nice and clean. Greater than or equal to 15. And now I do the two separate inequalities. The first one, I keep it exactly the same, but I get rid of the absolute value symbols. So I've got -4x plus 9 greater than or equal to 15. Now this is greater than, so is this going to be and or? It's going to be or. All right, and then let's do this. It's -4x plus 9. So we don't really change that. But now we got to change the inequality. So it was greater than, we make it less than or equal to. It was +15, we make it what? -15. All right, just like we did on the homework yesterday. Almost just like it. We just have to change the inequality. That's the only thing new, really, about yesterday and today. Let's do this. -9 greater than or equal to, what's that, 6? Divide by -4. But if I divide by a negative, what do I have to do? If I divide by a negative, I got to change it to less than or equal, reduce it, 3 over 2, -3 over 2. All right, so that's one of my solutions. Let's do this one. Subtract 9 from both sides. I got negative 4x plus 9 less than or equal to, what's that, negative 24. Subtract 9 from both sides. So that's negative 4x is less than or equal to, what's that, negative, did I do that right? What did I do? Oh, I kept the 9 there, didn't I? Boom. Yeah, I didn't put it here though, but I just forgot to do that. That's, what did I do? I messed up. Oh, I already subtracted the 9. That's what you're saying. Right, got it. My bad on that. All right, so it's negative 24. Divide both sides by negative. Again, we're dividing by a negative, so I'm going to take this one, and I'm going to change the direction of that one, and that's just 6. So there's my 2 answers. And you're going to put an or in between. Now we're going to graph it. All right, this is negative 1.5, correct? 1.5. So I'm going to put that right here, negative 1.5. And this is 6. I'm going to put that right there. And what's the graph going to look like? They're both less than or equal to, so I'm not going to put an open circle. What am I going to put here now? Closed circle. So close that circle in. And then same thing with the 6. Close that in. Shade it in. All right, now this says x is less than negative 1.5. Goes that way, and greater than positive 6, and that goes that way. And there you go. There's your solution, and there's your graph. All right, I've got time to do the next couple, and then that's about it. All right, these are a little different, so it's not exactly what we just, well, it is, but when you see the answer, it's going to look a little weird. All right, this says what? Absolute value of x is less than negative 3. So what is the less than? Is it and or? It's and, right? This is the and. So I'm going to go x is less than negative 3, and that makes a big difference on how the graph looks. And x is, what do I do with that? Make that greater than, change that, that's positive 3. So let's think about the graph right now. I want to find numbers that are both less than negative 3 and also greater than positive 3. Do they exist? Because what's your graph going to look like here? If I was to graph this, I would say it would go like this and it would go like this, right? Open at both ends. But the problem is, you got to have an and. Do I have a number? Is there any numbers that fit both of these graphs? Is there a number to the left of negative 3 that is also to the right of positive 3? There's none that exists. So what is your answer for this? There's no solution. And you could have told right off the bat that there was no, well, maybe not. I shouldn't say that. Okay, so this would be no solution because of that being less than, because there's nowhere where they meet. There's no intersection between them. All right? So that would be no solution. You would be tempted, wouldn't you, to circle both of those and then give me that graph, wouldn't you? All right? But here's where the solution would need to be, but there's nothing in there. So there's no solution to this at all. All right? And that's the key, knowing that the less than is and. Let's do one more. Example 5. And we're just going to do the same thing, but instead of less than, guess what we're going to do? Greater than. All right, let's look at this. So what is the greater than? Is it and or? It's or, okay? So x is greater than negative 3, or x is, change the sign, the direction of the inequality, and change the sign of that number. There we go. So now let's think of this. Put a negative 3 here and a positive 3 here. Whoops, positive 3. So we want to figure out all the numbers that are greater than negative 3. So what happens here? That keeps on going that way. Or all the numbers that are what? Less than positive 3. Give me numbers that fit either one. That means all the ones that are, it actually mean all of them, wouldn't it? Because you could pick either negative 3 or you could pick a number that's bigger than 3. You can pick any number, couldn't you? So this is all the real numbers. This is all the real numbers. If you wanted to write it with that fancy R, you could do that, circle that, that's fine as well. Do you understand this? So it's or. What if it said and? Then it would just be the ones that overlap. But the or, it could be any of these or it could be any of these, which means it could be any number on the number line. All right? So here's your homework. Page 48. And you're doing 1 to 27, just the odds. Isn't that nice of me? All right, so there you go. 1 to 27 odds, that's your homework. Have a good weekend. See you on Monday. We only got 3 days next week, all right?